Assalamualaikum. My name is Nur Pasha binti Muhammad Rashid. My matrix number is CE210069. Okay, I will present for the project signal system. For this part, do a Fourier series analysis of the signal given for a section and plot the signal in time domain for 5, 10, and 20 harmonics. After that, analyze the signal both in time domain and frequency domain. And the period of the signal will be given by the lecturer. Assume duty cycle of the signal is 50%. That means tau equals 0.5 T naught. Okay. For the F naught, my group is 120 kilohertz, and for the FC, 800 kilohertz. Okay, this is our simulation for the F naught, 120 kilohertz for the fundamental frequency, and for the FC cutoff frequency, our value is 800 kilohertz, and our duty cycle is 0.5%. And for the period of the signal, T naught equal 1 per F naught. Okay, at first we define for the time domain analysis and initialize signal vector for 5 harmonic, 10 harmonic, and 20 harmonics. To generate the signal with 5, 10, and 20 harmonics, this is the coding. Then for the frequency domain analysis, we define the number of samples and sampling frequency, and then perform the Fourier transform. This is the coding. Then we generate frequency axis F equal Fs. Multiply by negative n, divide by 2, n divide by 2 minus 1 divide by n. And for the plot and then we plot the signal in time domain. This is our coding. For the plot, we need time, amplitude, and signal in time domain 5 harmonic, signal in time 10 harmonic, and 20 harmonic. After that, plot the signal in frequency domain. We need to mention frequency, amplitude, and signal in frequency domain 5 harmonic, 10 harmonic, and 20 harmonic. Okay, after that, I run my coding. Okay, this is our output from the coding. This is signal in frequency domain 5 harmonic, 10 harmonic, and 20 harmonic. And this is the signal in time domain 5 harmonic, 10 harmonic, and 20 harmonic. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman bin Muhammad Sufyan, and I will continue the presentation for task 3 and task 4. So for the task 3, our group need to construct a low-pass filter with frequency response characteristics. So this is the coding for the filter signal. So we need to assume resistor to any value, but we choose 10 k ohm. And we assume capacitor 0.01 microfarad. And this is the frequency for our group, which is 120 k hertz. And then frequency cutoff 800 k hertz. So this is the formula that we need to use to get the frequency response. So I will run the MATLAB simulation. And this is our low pass filter in time domain. So for the frequency response, I will make a new coding here, and then I will just simulate it again to get the frequency domain frequency response. So this is our result, low pass filter in frequency domain. Thank you.
Assalamualaikum and hi, my name is Nik Muhammad Aizat bin Jaafar and my number is CE200044. So today I will continue about this project in a system task 5. This is Proteus software was used to create a low pass filter. So the resistor we use is value is 10k ohms, while the capacitor value is 19.894 picofarad. So according to the result, the graph is produced by the Proteus program was nearly identical to the simulation produced by the MATLAB software. So when we plot at 3 dB, the volume of space is 1 mega. This is because each program has a unique coding, even if the frequency, resistor, and capacitor value are entered. This is due software well. So according to the result, the graph produced by this Proteus program was nearly identical to the simulation produced by the MATLAB. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Darwish bin Mutawadir and my metric number is DE 2036. So, this is the project that we do for Sns system. So, I will do a task which is investigate the effect of having a lower or higher duty cycle, set duty cycle for the case of tau 10%, 20%, 30%, 70% and 80%. So our group we will use this FO which is have 120 kHz and FC 800 kHz. So this is our coding for this is 5 harmony. So we have a FO is 120 kHz and FC is 800 kHz. So this is the duty cycle. We need to search for 0.1, 0.2, 0.3, 0.7 and 0.8. This one is 0.1 for the 10%, 20%. 0.3 is 30%, 70% and 80%. So this is the formula for the TO, which is 1 over FO for a period of the signal. So this is the time domain analysis. This is the formula for time vector, and this is for the initialize signal matrix. So this is the generate the signal for the different duty cycle, which is for this is the coding. And this is for the generate the signals with 5 harmonics. There is this one, and there is the formula for harmonic. And then we need to apply the duty cycle. This one, put the formula, and then frequency domain analysis. There is a number of sample, and then there is the sampling of for the frequency formula. Then we need to perform the Fourier transform for each signal. This is one, and then we need to generate the frequency axis. This one, the formula, just put into the coding. And then for the plot the signal in the time domain, there is the coding. And lastly, we need to put the plot the signal in the frequency domain. This one the coding. So let's run. So this is the signal in time domain. This is 10%. This is for the 20% and 30%, 70% and 80%. And then there is the signal that we get for a frequency domain. This is 10%, 20%, 30%, 70%, and 80%. This is for the 5 harmonic. And then for the 10 harmonics, the coding is same, but they need to change in here, which is we change it into 10 because there is 10 harmonics. So just run. So we can see there is the time domain, 10%, 20%, 30%, 70%, and 80%. They are the duty cycle. And this one is a signal in frequency domain, 10%, 20%, 30%, 70%, and 80%. So this is the my 10 harmonics coding. And this is the last one is 20 harmonics. So it's same like before this coding. So we need just to change their harmonics. They need to change their harmonic in here. Just change it into 20, and then let's try. So this is the signal in time domain, 10%, 20%, 30%, 70%, and 80%. And for the signal in frequency domain, this is for the 10%, 20%, 30%, 70%, and 80%. So that's all from me for task 6. Thank you.